Thank you very much. That's the first time I have someone reading my biography. That was very spooky, but thanks. Usually do those kind of things for important people, you know. That was, thank you for that. Okay. So anyway, so we're both from Italy. That's why we have weird names that no one can pronounce. But that's okay, because when I speak in English, I even mispronounce my own name, so it's perfectly fine. So we're talking about playing with a satellite navigation system and playing with the traffic message channel. So what we have here is our gear that we made for, you know, showing you our research. We also have a big antenna here. So if you make stupid questions, we just sterilize you with this antenna. Okay, so be careful. Okay, so what are we going to talk about? So this is what happens when, you know, someone that is involved with security buys a car with a satellite navigation system, which is built in and has, you know, some cool capabilities about, you know, giving you traffic information. So I bought a new car last year. So, and of course, the first thing you do is not like driving your car and enjoying it. It's like thinking, that could be interesting. I could try to hack this system. So let's see if that works and if I'll be able to do a research and then, you know, get free tickets around the world for doing conferences. And actually, that worked pretty well. I mean, we've been presenting this work all around, and we're very glad to be here. This is the first time at Hacking the Box. And Daniele works with me with our company. He's doing hardware stuff. He's currently setting up the things for the demo. So what are we going to talk about? So modern in-car satellite navigation system, they have something called the traffic message channel, which is being used for giving you traffic information like queues, accidents, whatever. And you can use that information for enhancing your route home. And this is called the TMC, so Traffic Message Channel. And the full name of the protocol we're going to play with is RDS TMC. So why did we do this thing? So first of all, because it's fun, and owning a car is like priceless. It's very 80s because we're dealing with a technology which is, we're dealing with two technologies. One that is new, but it uses a very old transport protocol, which is very old and very 80s. So, you know, we wanted to play with that. And also because the problem is that people implicitly trust these kind of things. If you're driving a car, you would never expect that, you know, someone might tamper with your data, okay? It's far from being expected. And since there's a matter of trust here, we wanted to exploit that and see and raise awareness about the fact that this system needs to be more securely designed because of the future. And also, chicks will melt when you show this. It's good for getting girls. And we'll prove our point with a video. Okay, so radio data system. So RDS is used for transmitting data over FM radio. Okay, so whenever you listen to a radio station and you see the name of the station on your radio, that's RDS working for you. Okay, so the way it works, what happens is that, so this is the FM spectrum. So here you got a mono signal. Here you got 19 kilohertz pilot tone. Here you have the stereo component. And right here at 57 kilohertz, you have a subcarrier that carries zeros and ones. So a data signal, which is digital. Okay. So this is a way where we can use an existing, you know, normal analog radio and transmitting data. And RDS is used for lots of things. So as I was telling you, it's used for the name of the station. It's used for giving you alternate frequencies. So when you're driving and you're setting your stereo to a radio station and you're going to a different region, the frequency changes because in most countries, the frequency for a radio broadcaster is not the same across, you know, different regions. And so what happens, the radio gets an alternate frequency, and when it lost the primary one, then it falls back on the secondary one. You can also have the program time, so you can no one uses that, but you can say, I want to only listen to jazz music or whatever, and then the RDS tells you what kind of music you're listening to, and then you can put filters on it. It's not used at all, but the protocol you know, allows that. You can get news override. So you're listening to a CD, and you tell your radio station, if there's a traffic program which gives me useful information, please stop the CD and let me listen to the radio. Okay? So if you have that functionality, that's carried by the RDS. There's one bit which is set to 1 instead of 0, and that means traffic program, and then you know you can use it. And so what they did for navigation system, they said, okay, we have RDS already. So why don't we use RDS for carrying traffic message information? So this way, we don't have to build, new hardware, new infrastructure. We can just use existing, radio broadcaster for sending those kind of information. So what happens is that you have traffic messages, which are gathered by, I don't know, police, users reporting problems, or sometimes you have automated stations that they can detect if there's a queue or not. One of the very modern things they do, when you have mobile phone cells, if they detect a very, very high density of mobile phones in a specific area on a highway, then they assume there's a queue. And that's one way for automatically giving you a warning about queues. Okay? So what happens, they relay that information to a radio broadcasting station. Okay? And then that information is being placed into an RDS stream, and then your navigation system is going to fetch that information and show to you warnings. And we're going to see what those warnings are. Okay? So RDS is very old. It got introduced, lots and lots of years ago. But TMC is fairly new. It was invented in Germany, or else, in 1997. So Italy got it in 2004. And just to show you how relevant this is, Australia will get it only in 2007. Okay? So it's a public specification. And even if it uses a very, very old protocol, it's still it's very, very modern. Okay? So it's implemented in I would say 90% of satellite navigation systems which are built in your car. So if you buy a car in Europe with a satellite navigation system which is built in, you get TMC. And you can buy handheld devices, so handheld GPS devices. And if you get the very high-end model, you get TMC built in directly. Or you can also buy an external antenna that acts as an FM receiver, and then you can decode and see TMC. So RDS TMC is available in both free, as a free service, so you don't have to do anything. You just turn on your your navigation system and it works. And most people, they're not even aware of that. They see traffic message coming in and say, oh, okay, that's cool. That's a cool functionality. And there are also some commercial services, and I'm going to talk about those. But the majority of services are free, except in the States, which is a very big commercial provider. And TMC can also be transmitted over other mediums, so not only RDS, but also over digital radio. This research only focuses on RDS, but on digital radio is going to be the same thing. The problem still exists. And the problem is that the data is in clear text, it's not authenticated. Old news about computers, but on cars, they have to rediscover things, all over again. And so that's what we're going to talk about. So this is a TMC terminal. So you can see we have patchy fog, the name of the road here. We have how far the event is from our position. So in this case, it was 250 kilometers. Okay, slow traffic. And what you can do, you can click on the event. And when you click on the event, you see the relevant map with an icon on it, and then whatever message you want. And this is like on demand. You have a list, you click on it, you see things. But when you are plotting a route and an event is affecting your current route, then you're going to either get a pop-up or different messages. Okay? So you can either browse the current list of events, or navigation system is going to tell you, look, there's something, there's an accident, what do you want to do? Okay? So the problem is that there's no form whatsoever of authentication of any data, and it's clear text. Okay? So we thought, we could play with this and do whatever we want, and let's see how severe is the problem, and if we can do that easily without spending thousands and thousands of dollars. So one of our goals was building very cheap hardware to build a pirate station, a pirate radio station for sending those kind of signals, and see what happens if we send those signals to a navigation system. Okay? And so we use off-the-shelf components, and so this equipment doesn't cost more than $100. So it's very, very cheap. And we play on keyboards. We use keyboards all day, and we were able to do this. So if we can do this, believe me, anyone here can do that, even if you have no experience in electronics at all. Okay? So this is the victim. So usually in IT security talks, you have like the victim is like a computer, a server. This is a car. That was one of my motivation for the talk. I mean, isn't that cool? You can put on the slides, your victim is a car. I mean, that's kind of sweet for me. And so the first thing we needed to do was actually understanding what was going on. So we can see the messages on my navigation system. So we wanted to understand actually how the protocol is made, because we need that knowledge for actually playing with it. Okay? So what we're going to do, we need to get a raw FM signal. So we don't need to get the audio components. So like left and right that you get on the speakers, right, in your car. We need to get the raw dump of data because we want to access the 57 kilohertz subcarrier, okay? So the way we do that, so we can use, there are modules for most onboard PCI cards for PC that can give you audio, FM radio, and also television. So if you buy one of those cards, which costs like $40 or $30 on eBay or something, there's a tuner on it, and there's a pin on the board. So this is here, this is a PCI. This is just a standard PC, and this is a PCI board, which is used for television. And the tuner here also gets FM radio. And there's a pin on it which you can hijack for getting the raw FM signal, which is MPX. Okay? So that's the first part. We extract the raw FM component, okay, with that module. And in that website, you can get a list of modules that support this kind of functionality. Okay? So once we have the signal, what we need to do, we want to completely trash the audio part, and we want to get our RDS signal and try to decode it. Okay? So for that, we use a TDA733OB, which is a standard demodulator. In every radio, FM radio, you have that chip. There are 2 chips around. 50% of all radios have that chip for demodulating RDS. And you can go to electronic shop and ask for one of those, and it costs like, how much does it cost? $5? Yeah, it's like insanely cheap, okay? And also, so what we want to do, we want to get data from it. And we want to do that with a PC. Right? Because we want to be able to access our data and decode it and whatever. And so what we do is we use a PIC, a programmable integrated controller for converting the information that this chip is going to give us in serial, so that we can hook that to a serial port and then get all zeros and one and get our data from our FM stream. Okay? So once we have all these zeros and ones, what we do, we need to decode them. For decoding, then we wrote our own software, which is called RDSD, which is open source, is available. There's another project which is open source around, but it's kind of old and it's not getting updated. And it just focuses on basic RDS. It doesn't focus on TMC at all. So we decided to redo the whole thing. Okay? So this is the board. Since you cannot see it here, this is the board. And what you can do, you can hijack a pin here, and then you get the MPX signal. Okay? So it's very easy. You solder, you be there, and you get the raw signal. And so, you want to talk now? Okay, yeah.
This is our sniffing setup. It's pretty simple. We got the MPX signal from the VHF tuner. And after we send our analog signal to our sniffer circuit. Okay, our sniffer is really simple, as you can see from the image. The main components of the circuits are the TDA7330. That's the RDS demodulator, as Andrea said before, and the PIC, the microcontroller, the PIC 16F84. We use we use that PIC for many reasons. First of all, it's very simple to program. Its assembly, it's quite simple, so it's very easy to program, and also it's very easy to build a programmer circuit for that.
Okay, so this was the assembly part. Okay, we took 2 days for doing it with a very, very advanced lab. This is my bed. Yeah. Here we're just warming the circuit. Okay, this is sniffing circuit. Yeah, that is very simple. It's also over here. You cannot see, but then if you want to jump here after the talk, we can show it to you all the gear. So if you want to build it on your own, everything is published, and you can do it. It's very, very simple. I mean, we did it, so anyone can do it.
It's trivial. Okay, so the PIC is able to get to us an important information about the quality of the signal that we receive. So we are able to distinguish between a bad quality data stream from we are able to distinguish between a bad quality data stream and a good quality, and that's really important because